Hello, this is Dennis. In this video, I'm going to unlock the secrets of chemical-free dechlorination and disinfection using the HOD UV. The HOD UV is a proven chemical-free dechlorination and disinfection technology for RO membrane protection. It effectively removes free available chlorine and the associated harmful effects. It eliminates or significantly can reduce biofouling, eliminates scaling from the overfeeding of bisulfite, and decreases an RO's cleaning in place. It extends membrane life and reduces overall maintenance. It improves membrane performance and cycle water chemistry. The HOD UV is environmentally friendly, simple, safe, and secure. Safe for water, no hazardous chemicals or harmful byproducts. Safe for employees, no chemical handling. Membranes are fouled with numerous organic and inorganic matter. Further, the aggressive chemicals used to clean a membrane are strong enough to degrade the membrane surface. RO membranes have numerous reasons for membrane failure. The primary reason is biofouling. Exasperated by the stickiness of biofouling, mineral and colloidal particles will enhance the membrane's fouling. Essentially, biofouling can account for 80% of a membrane failure. In a collaborative effort between the Southern companies, the Southern Research Institute, the Electric Power Research Institute, and Atlantium, the HOD UV was extensively studied on membrane protection and performance. As a result of this study, EPRI awarded Plant Bowen their 2019 Technology Transfer Award. As you can see from the membrane's normalized differential pressure analysis, the results over a 5-year period were extraordinary. Without the HOD UV, the membrane differential pressure started at 28 psi and exceeded 60 psi in 3 years, with numerous CIPs per year. Using the HOD UV, the membrane DP started at 28 psi and went to 35 psi in over 5 years, further needing a fraction of the CIPs. Truly extraordinary. In a similar study, a cottonseed processing company in Texas biofouled and replaced membranes yearly. Using the HOD UV, the membrane postmortem analysis showed the membrane was acting as if it was brand new after several years in use. Chlorinated water is used to control biogrowth, but if not removed, will oxidate and destroy a membrane surface. Activated carbon can be used to remove free available chlorine, but is an incubator for bacteria. Bisulfite is commonly used to remove chlorine, but can be a food source for bacteria, and the excess will slime the membrane surface. The HOD UV is a non-chemical alternative to dechlorinate and disinfect the water. A photon bullet dissociates the oxygen from the inert chloride molecule. By doing this, the damaging potential of free available chlorine is removed. A closer look into the water chemistry shows that the UV photon dissociates both forms of the free available chlorine into an inert chloride. As we see, both forms of free available chlorine exist around a neutral pH that typically feeds the RO membrane. And the wavelength absorption spectra of both forms of free available chlorine validate that low pressure lamps have little effect, and the high resolution of a medium pressure polychromatic lamp is required for effective treatment. As we see, the energy required to dissociate the free available chlorine is over 1,000 millijoules per centimeter squared. The HOD UV exceeded expectation by removing the free available chlorine to non-detect or less than 0.01 ppm. Essentially, chemical-free dechlorination is an advanced oxidation process that will affect trace contaminants and TOC. First is direct UV photolysis at a very high energy. Second is the formation of the hydroxyl radicals during the dissociation process. As we can see from this chart, hydroxyl radicals have the highest redox potential of the common oxidizing agents, stronger than ozone, peroxide, chlorine dioxide, and the most commonly used free available chlorine. The dechlorination process operates at 1,000 millijoules per centimeter squared. Simple disinfection uses energy around 40 millijoules per centimeter squared. Essentially, no bacteria gets through the HOD UV chamber. Using the HOD UV, the EPS, or the extracellular polymeric substance, is effectively being controlled. On a membrane surface, the EPS is the bug glue and acts like concrete. The bug glue cements the mineral scale and colloidal solids to the membrane surface. Without the EPS, the mineral scale and colloidal solids are easily removed. One medium pressure polychromatic lamp in an HOD UV with internal reflection does more work than 5 to 7 medium pressure lamps or 16 to 20 low pressure lamps in a traditional UV system. We've now unlocked the secrets of chemical-free dechlorination and disinfection using the HOD UV. The HOD UV with internal reflection chamber effectively recycles and concentrates the energy. For that reason, the HOD UV is less than a third of the cost of a traditional UV. HOD UV significantly reduces biofouling and the EPS, or bug glue, that cements mineral scales into a membrane. And HOD UV eliminates the harmful use of bisulfite that is associated with scaling overfeed and a food source for biogrowth. Finally, the hydroxyl radical formation enhances TOC reduction and trace contaminant removal, which can improve water quality and cycle water chemistry. Feel free to email or call me if you would like application briefs or case studies specific to chemical-free dechlorination and disinfection using the HOD UV. Don't forget, like and subscribe to my videos. Thank you for watching my video.